All right, hi guys, welcome back. Lesson 6 for my favorite 7th graders. I hope you're doing good. Today we're going to talk about divisibility and factoring, and this is super, not even factoring, finding the greatest common factors, and this is super important because you're going to use this a ton in algebra. And even the division part, I find myself using it for all sorts of things. So, first things first, let's start with something easy, right? How do we know that something is divisible? So, divisible by 10. Divisible by 10, right? And I told you to get a 20 by 20 multiplication chart, so hopefully you have that. If you do not, though, let's look on this one together. All right, so right here we have 10 times 1 is 10, 10 times 2 is 20, 30, 40, 50, 60. How do we know if something is divisible by 10? It ends in a 0. All of those end in 0, okay? So that's a divisibility rule, and that's a pretty easy one straight off the bat. Today we're going to talk about all those divisibility rules, how many different ones that there are, okay? We're going to talk about 2, 3, and actually I'm going to write it down here a little bit. 2, 3, or 9. 3 or 9 are closely related. 5 and 10. 5 or 10. Or 10. I can't think of any others that 6, 7, 8, 9, 10. No, those are the important ones, really. Okay, so here's the first rule we talked about was 10, right? Let's talk about 2. How do we know if something is divisible by 2? Let's go back to that 20 by 20 multiplication chart and look at our 2's. We have 2, 4, 6, 8, 10, 12, 14, 16. If you take a note at those patterns, those sequences, right? All of them end in an even number. So they all end in an even number. So make sure, students, that you're writing in your notebook as we do this, because you're going to want to take notes on this. This is really helpful. So 2, divisibility rules. For 2 ends in an even number. So an example of that would be 62, right? Or 78, or 2,918. That would be, all those are divisible by 2, right? All right, next one is going to be 5 and 10, and I'm going out of order here for a reason. 3 and 9 are my favorite, and I can't wait to talk about those. So for 5, take a look at these guys right here. 5, 10, 15, 20. I hope this focuses. 25, 30, 35, 40. Okay, so all of those end in a 0 and a 5. So what you want to write on your notes are ends in 0 or 5. Ends in a 0 or 5. Things like that would be 3,285 or 45 or 70. All those are divisible by 5, okay? 10, we determine, ends in a 0. Ends in 0. So things like 200, just leave it at that, 200, 150, 70, 80,500, and 10 is what I wanted to go for, right? Any of those guys are all going to be divisible by 0. Divisible by 0. Okay, so 3 and 9. These are my favorites, okay? 3 and 9. How do you know if something is divisible by 3? What we can do is, for example, let's look at 54, okay? So actually, let me write this so you have some good notes. Divisible by 4. Divisible, not by 4, by 3. By 3 or 9. Add up all the digits. So you're going to add up all the digits. And what that means is that if you have 45, for example, that's going to be 4 plus 5. That equals 9. Folks, does 3 go into 9? Yes. Then 3 is going to go into 45. Does 9 go into 9? Then yes, then 9 is going to go into that number as well, okay? Something like 15. 1 plus 5 is 6. Does 3 go into 6? Yes. Therefore, 3 is going to go into 15. Does 9 go into 6? No. So therefore, 9 is not going to go into 15. So this works with some good ones. We've got 800 and 813. Let's try 813, okay? I'm trying to make these up as I go along. Bear with me. What we know is 8 plus 1 plus 3. That is going to give us 12. Does 3 go into 12? Yes. So 3 is going to go into this number here. Does 9 go into 12? No. So 9 is not going to go into this number right here, okay? That goes for, let's say we got this. Okay, so we got 819, 819. 8 plus 1 is 9, 9 and 9 is 18. Keep breaking it down, okay? 1 plus 8 is 9. Does 9 go into 9? Yes, so therefore 9 is going to go into this number here. Hopefully that makes sense. If you have any questions, make sure to let me know. These are all really important, especially when we get onto the next part. So finding the factors of numbers, Guys, when you find the factors of numbers, I want you to do it exactly as how I show you. This is really important when you get into algebra, when you start to get into factoring. It's super important that you go in order and you go the way I do. You may have seen this in the past where it's like, okay, here is 12, all the factors of 12. 1, 2, 3, 4, 6, right? 12. And you're like, okay, make sure I don't forget any, right? The way that I do this is a little bit different, and it ensures that you don't forget any. So if I want you to find all the factors of 12, I would list 12 like this. We start with the easiest one, 1 times 12, okay? After 1 comes 2, 2 times 6 equals 12. After 2 comes 3, 3 times 4 equals 12. After 3 comes 4, and 4 is already on the board on this side. Therefore, we're done, okay? So that's how you're going to be finding the factors. You're going to go 1, 2, 3, 4, and keep finding them all the way until you get all of them, okay? So taking a look at some of these examples here. What was I looking at earlier? All right, so we're going to do 2 things. First, we're going to find all the factors, the greatest common factor. I'm looking at example 3 on page 30. Finding the greatest common factor of 18 and 30. 18 and 30. All right, so I'm going to start over here with 18. Start with your easiest one. 1 times 18. Good. After 1 comes 2. 2 times 9. Good. After 2 comes 3. 3 times 6. This is where it's really important you know your multiplication tables. All right, after 3 comes 4. Does 4 go into 18? No, so we move on. After 4 comes 5. Does 5 go into 18? Nope, so we move on. After 5 comes 6. 6 is already on the board on this side, so we are done. Now, we're going to list all our factors of 30, the same idea. 1 times 30, 2 times 15, 3 times 10. After 3 comes 4. 4 does not go into 30, but 5 does, right? Because it ends in a 0 or a 5. This is where it's important that you know your divisibility rules. So 5 times 6. After 5 comes 6. 6 is already on the board. We got this. Now, to find the greatest common factor, what I'm looking for here is the largest number that these guys have in common. So you start here at 18, nope. 9, nope. 6, yes. 6 they have in common. They also have 3 and 2 in common, but I am looking for the greatest common factor, so I want to see the largest one that is there. Good. So 6 would be your greatest common factor for those guys. Let's look at, also, like I said before, I'm in the Math 87 second edition book, okay? On page 30, you can see that right here at the bottom, there are these tests for divisibility. And those are basically the notes that I was just having you take, right? If it can be divided by 2 if it is an even number, a 4 if the last 2 digits can be divided by 4. Anyway, those are all the rules. You may want to copy those down and tape them into your book or just handwrite them down. You'll notice this one goes through 4 and 8. Those aren't necessarily important because 2 will work for both of those. So I'm not so worried about 4 and 8, but you definitely need to know 2, 3, 5, and 10, okay? If you know 3, you probably know 9. If you know 2, you probably figure out 4, but really I just 2, 3, 5, and 10. Those are the most important, okay? So with that in mind, which whole numbers from 1 through 10 are, I'm looking at example 4 on page 31. Which whole numbers are through 1 through 10 are divisors of 90, 60, 1 through 10. So I'm gonna write 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Straight off the bat, this ends in 0, guys. If it ends in 0, it's a 10 or a 5. 10 and 5 go into that, right? 1 always goes into everything, so that's easy straight off the bat. You can forget about 1. Is 0 an even number? It's neither even nor odd, but for the purposes of this, yes it is, and so it's divisible by 2. Now let's do that trick for 3 and 9. 9 plus 6 plus 0 plus 0, so 9 plus 0 plus 6 plus 0, all that equals 15. Does 3 go into 15? Sure does, so 3 is going to go into this number. Does 9 go into 15? No, it does not, so 9 is not going to go into this number, okay? The rest of these, not as important. I really want you to focus on those other ones, so don't worry about 4, 6, 7, and 8, okay? But I really want you to focus on the others. Good, all right, so, oh, and if you look at the answer, 4 and 6 are also go into those two. But if you know 2, then you'll be able to do 6 and 4 just fine. Okay, so let's move on to practice on page 31, A through J. What I'd like you to do now is stop the video, pause it, see if you can't give that a shot on your own, and then return back and we'll go over it together, okay? For those of you who are ready to go on, we have A, list all the whole numbers that are factors of each number. 25, so first one for 25, we start with something easy, 1 times 25. Does 2 go into 25? No, because it doesn't end in a even number. 2 plus 5 is 7. 3 does not go into 7, so 3 is not going to go into this number. So it's not 2, it's 1, yes, 2, no, 3, no, 4, no, because we know 4 times 6 is 24, so it can't be 25. So 5 would be next, and that's 5 times 5. So we're done, because now we're looping back around, right? So we're good. Those are all of our factors. Let's look at B. 24. All right, 1 times 24, I like that. 2 times 12, 3 times 8, 4 times 6. After 4 comes 5. 5 does not go into 24. After 5 comes 6, and 6 is already on the board, so we're done. All right, C is 23. 23, 1 times 23, and then we know 2 doesn't, we know 3 doesn't. We know that 23 doesn't multiply by anything else here. This is what's called a prime number. So make sure in your notebook you write this down. Prime numbers can only be multiplied by 1 and itself. Example, 1, 2, 3, not 4, because 4 can be 2 and 2, 2 times 2. 5, yes, not 6. No even numbers after 2 can be prime because they're all divisible by 2. But not 6, but 7, yes. Not 8, not 9, not 10, 11, not 12, but 13. Really, those are the only prime numbers you'll need going for the first set, right? There are, of course, an infinite number of prime numbers, but if you know these as your prime numbers right off the bat, that's a good position to be in. So make sure you write that down and put that in your notebook. Okay, so getting back to these practice questions, let's look at D. List the whole numbers from 1 to 10 that are factors of each of these. So we've got D. What I want you guys to do on this, we want to know if it's 1, 2, 3, 5, 9, 10, okay? Skip 4, 6, and 8. I don't really worry about those. So for D, we know 1, 2, 6, 0. 1, 2, 6, 0. Well, we know it's going to be, do we know 1? Yes, that's easy. 1 is 2. Yes, because it ends in an even number, so 2. Good. 3, let's add these up. 6, 7, 8, 9, plus 0. Does 3 go into 9? Yes, 3 is going to go into this number. Now, while we're on it, does 9 go into 9? Yes, so 9 is going to go into that number. But I jumped a little bit ahead here. Let's go back and do 5. 5, the rule is it has to end in a 0 or 5, and it does, so it's going to be 5. And then 10, yes, because it ends in a 0. Okay? So that was D. Let's look at E. 7,300, or 73,500. 1, yes. 2, yes, because it's even. 7 plus 3 is 10, plus 5 is 15. Does 3 go into 15? Yes, 3 is going to go into this. Does 9 go into 15? No, so 9 is not going to go into this. Does 5 go into this? Yes, because it ends in a 0 or 5. And then last one, 10, because it ends in a 0. All right, so for F, we have 3,600. All right, so we know that 1 goes into it. What about 2? Yes, because it ends in an even number. 3 plus 6 equals 9. Does 3 go into it? 9? Yes, then 3 is going to go into this number. 5, yes, because it ends in a 0 or 5. 9, well again, 3 plus 6 is 9, and 9 goes into 9, so therefore 9 is going to go into that. And then lastly is 10, because it ends in a 0. Good. All right, so let's look at G. List the single-digit divisors of 1356. 1356. This is the same thing asking the single-digit divisors. So what that's asking is find the factors of this that are single digits, which are basically going to be this. Okay, so let's just do that. 1, yes. 2, yes, because it ends in an even number. Now we've got to do our adding. 1 plus 3 is 4, plus 5 is 9, plus 6 is 15. Therefore, does 3 go into 15? Yes, it does, 5 times, and therefore 3 is going to go into this. 5, no, because it has to end in a 5 or a 0. 9, well, let's go back. If we add those up again, 1 plus 3 plus 5 plus 6, we get 15. Does 9 go into 15? No, so 9's not going to go into this number. 10, it doesn't end in a 0. So basically, those are going to be our important ones right there. All right. All right, so for H, the number 7,000 is divisible by which single digit numbers? Again, we're going to do the same thing. 1, 2, not 3, because 7 plus 0 is 7, and 3 does not go into 7, so 3 is not going to go into that. Same with 9. 5, yes, and 10. 5 and 10. All right, so that was H. I. We're going to list all the common factors of 12 and 20. So first we have to find the factors of 12 and 20, and then we're going to list the common ones. Again, we want to go in order. 1 times 12, 2 times 6, 3 times 4. See how I did that? And then after 3 comes 4, it's already on the board. We're good. 1 times 20, 2 times 10. Does 3 go into it? No, because 2 plus 0 is 2, and 3 does not go into 2. 4, yes. 4 times 5, and after 4 is 5, and it's already on the board. So the common factors that we have here are 4, 4, and 2, okay? The greatest common factor is 4. However, it's just asking us to list the factors. For J, we're going to find the greatest common factors between 24 and 40. 24 and 40. We start with 1 times 24, 2 times 12, 3 times 8. After 3 comes 4 times 6. After 4 comes 5. 5 does not go into here. And after 5 is 6, and 6 is already on the board, so we're good. 1 times 40, 2 times 20. 4 plus 0 is 4, and 3 does not go into 4, so 3 is not going to go into this. 4 times 10. 5 times 8. After 5 is 6, that doesn't go into it. 7, no. 8, 8's already on the board, so we're done. So to find the greatest common factor between these guys, all right, let's work our way backwards. It looks like 24, 12, 8. It looks like 8 is the biggest one that we have. We also have 4 and 2, right? 4 and 2, but we want the biggest one, the greatest common factor. So we want 8. Okay, guys, finding the factors is really important for reducing fractions, for factoring when you get into algebra, things like that. You're going to use factors over and over again, so it's important you know your multiplication tables. If you do not, you will be struggling. Okay, so That was it actually for all these questions. If you have any questions, let me know. Otherwise, we'll see you for lesson number 7, guys. Thanks so much.